Hello everyone, I hope you all are doing great. Let us begin day 3 of Kubernetes where we are going to do deep dive into pod. So, few concepts which I am going to explain today is what is pod, how to create pod using kubectl imperative way, how to create pod using declarative way, how to access your applications and how to log in inside the pod. So, the very first thing comes to our mind is what is pod and what exactly the content of the pod. So the first thing is a container. What is container? Let us understand first container, then pod, and then we'll understand the concepts. So a container is a self-contained environment where we package applications and their dependencies. Typically, a container runs a single process. Although there are ways to run multiple processes, each container gets an IP address and can attach volumes and control CPU and memory resources. So, if you say Kubernetes, right? So, Kubernetes is a container orchestration system. What exactly orchestration system means? It is mainly used for deploying, scaling and managing the containerized applications. So then what is pod? A pod is a smallest deployable unit in Kubernetes that represents a single instance of the applications. So suppose your application has 100 instances. So 100 different pod will be running to keep running that applications. So a container is a single unit. However, a pod can contain more than one container. You can think of pod as a box that can hold one or more containers together. So now what happens when you create a pod? There are multiple components involved in creation of pod. What are those components? Let us understand. So when we create a pod, you can see this screen clearly now. So when we create a pod, we always start or any of the Kubernetes resources, either its pod or its deployment or its service, its cron job, any kind of Kubernetes resource. So pod is a kind of resource. So what you do, you write the API version and version for pod is v1. Like what kind of object you are creating? It is a pod. P is capital, but it is pod. Metadata is like more detailed information about your pod. So what is the name? So name I am giving web server -pod. You can give whatever the name you like to give. Then labels, like labeling, you do the labeling. So in the labels you are telling it's a app and it is web server. Which environment? It's a testing environment, and some comments you are associating like annotations. In the description you are telling this pod runs the web server. In the specification sections, you give the containers, and in the container you give the name of container. What is the image? Which image you are using to create this pod and which port it is going to run. And restart policy, you don't want to restart. Restart policy is never, so you don't want to follow any restart policy. So now API version you understood is the version of pod. In our case it's v1. Kind is a object, it is pod. Metadata is mainly used to uniquely identify and describe the pod. Labels is set of key value pairs to represent the pod. This is similar to tagging in cloud environment. Every object must be labeled with standard labels. It helps in grouping the objects. Similar way, under the spec sections, we declare the desired state of the pod. Those are the specifications of the containers we want to run inside the pod. And containers, under the containers, we declare the desired state of containers inside the pod, like the container image, which port you want to run. These all details we put. Now, there are two ways to create a pod. One way is called using declarative way, which I was explaining you in this file. Like you create a file, you mention all the desired state in the declarative manner, and then you do it. The another way is called imperative way. What is imperative way? Like you run all the commands at the runtime just on the command line and it will create it. So in our case, if I have to create, suppose if I have to create the pod, I'm just going to copy this command in the imperative way and let us try it first. So I came here on my screen where minikube is running. How I can check? Minikube status. So minikube is running. Let us check if any pods are running. So kubectl get pods is the command to check running pods. So there is no running pods. Now what I am doing? I am just copying the command. What this command is doing? It is telling kubectl run and the pod name web server -pod. What image you are using? -- image is equal to nginx image. Restart policy is never. Which port? Port 80. And then labeling you are doing -- labels is equal to app is equal to web server. Environment is equal to test and annotations you are writing. Now just press enter and you got a message here clearly. Your pod web server pod got created. Now how I can verify? I can run the kubectl command. So kubectl get pods to check if pod is running or not. So you can see the name of pod is web server pod. It's in the ready state. So 1/1 is running, status is running, 0 restart, and age how many seconds before it is started? 13 seconds ago. So this will, you see now it's 30 seconds. So this is the actual time when the pod got started. So now your pod is running and this is a nginx image. So we should be having some web browser to see really it's running or not. So using kubectl get pod command, you can see your pod is in which state. Suppose you want to describe the pod, more details, then you can do kubectl describe pod and your pod name is web server pod and you can describe. So this describes all the details about the pod, like what is the IP address of the pod, what is name, what is the node IP address, what is the starting time, what are the levels associated to it, and then what all events happen. Like initially it started creating, then it created, it pulled the nginx image and finally it assigned it to the minikube. So this is the describe command. You can describe more details about the pod. Now if you want to delete, kubectl delete command, but before deleting if you want to see the logs, so kubectl get pods and suppose you want to see the logs, so you can see kubectl logs and your pod name is web server pod, and if you see, you can see all the logs associated to the pod. Now next thing is delete. Right now let us not delete. Before the delete, let us see if we can view the browser. But to view the browser, we have to take some actions. Like when I want to view it in the browser, we need to follow some steps. But before going there, let us understand next. So similar way, we can create the pod using declarative way. Like kubectl create -file name and then demo.yml, whatever my file name is. So first let us do one thing. kubectl get pods, delete the pod. So kubectl delete pod and pod name is web server pod, and see pod web server is deleted. If you do kubectl get pods, nothing is here now. Now you want to create the declarative way. So here I already copied a file. File name is demo.yml. So that file contains the actual code. So here if you see, I have a file called demo.yml and the same file is open here, which I explained you already in the beginning. So the same what steps we do using imperative command. Now I have written it into a file, and how to apply this file, let us see. So you can do kubectl apply -f and then your file name. File name is demo.yml. So you see your pod web server got created. If you do kubectl get pods, and you will see the web server pod is already running. So now you understood how to create the pod using imperative way, how to create the pod using declarative way. Now what's next? Next is how to get that applications running, how to assess that applications when pod is running. So kubectl offers a port forward command to assess running pod in Kubernetes cluster from the local workstation. So what command? kubectl-port forward. So kubectl-port forward, what this command is going to do? This command is going to help us to forward. Like your pod is running on port 80. I am telling that in my local system, forward it to 9080. So what it is going to do for us? It is now going to forward this on the port 9080. So you can see the Nginx homepage on 9080 once the port forwarding is done. So click enter. So now you can see port forwarding from this. So now if you go to the browser and if you go here in the browser, what you have to do? You have to do localhost colon 9080 and you can see your Nginx is in front of you. That means your pod is working perfectly. Let us do one thing. Let us cancel this as of now and let us refresh the page again. So what you are seeing, it's keep on refreshing and this is not reachable. So port forwarding has helped you to forward your port and again if you refresh it, it should be visible. So now you understood the concept of port forwarding. So here what exactly happens? kubectl binds the specified port in your local system. In our case, it is binding to 9080. It is then communicated with Kubernetes cluster API to establish a tunnel, a single HTTP connection to the required node and then to the specified pod and container port, that is 80. So this whole process has helped us to view our applications or access our applications in the browser. So this port forwarding is really one of the important steps when you want to view your applications into the browser from the local system. Now, suppose sometime what you want to do, you want to go inside the pod, like whatever the pod is running. If you want to go inside the pod, how you can go inside the pod? So if I want to go inside the pod, what I am doing, I just do kubectl and then what is the command? Execute means exec command. Then I is interactive terminal means you want to go to the interactive terminal and then name of the pod web-server -pod and then what next? /bin/sh. So what it is doing? Now it has taken us to the shell. And what is this? You can see uname command. So what you see? You are inside the Linux web server pod. So now using this kubectl execute command and I is called interactive shell. So you are telling let me go inside the shell of this particular pod and then you are telling bin/sh shell you want to go inside. So this way you can log in or go inside any pod. So I hope now it's clear for you guys how to view the applications into the web browser, how to log in inside the pod, and if you want to see any details, you can view any details. So this way kubectl execute command can take you inside the pod. Now, there is one important concept that is called pod lifecycle phases. So there are multiple phases of pod lifecycle. First is pending. What is pending phase? It means the pod creation request is successful. However, the scheduling is in progress. For example, it is in the process of downloading the container image. So if it is showing you pending, this means still pod is not scheduled. Something is happening in the backend. Running. Running state means the pod is successfully running and operating as expected. For example, the pod is in service and taking the client request. Succeeded. All container inside the pod has been successfully terminated. For example, the successful completion of cron job object. Then failed. All pods are terminated, but at least one container has terminated in failure. For example, the application running inside the pod is unable to start due to config issue and the container exists with non-zero exit code. Unknown. Unknown status of pod is, for example, the cluster is unable to monitor the status of pod. Sometimes cluster doesn't know the status of pod. In those cases, it will be in the unknown state. So these are the different life cycle of pod: pending, running, succeeded, failed, and unknown. So that's it about today's lecture. In coming lectures, I'll be coming about more deeper concepts of Kubernetes. Thank you so much guys for giving your valuable time.